Alright, so in this video, I'm going to solve the equation x to the power of x is equal to 3. So, to solve this, I'm going to first start by taking the ln, or natural log, on both sides. So I get ln of x to the power of x is equal to ln of 3. Now, an important property of logarithms is that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln x to the power of x, and I can move x to the front. So I get x times ln x is equal to ln 3. Now, I'm going to use an important formula called the W-Lambert formula. And it states that if I take the W of something in the form a times e to the power of a, then this is equal to a. So this is the W-Lambert formula. So in this case, I'm going to rewrite this so that it suits the W-Lambert formula. So we need to change this to be in the form a times e to the power of a. Well, how am I going to do that? Well, I'm going to first start by rewriting this x as e to the power of ln of x, because e to the power of ln cancel out, so that's just x is all that remains. So x is the same thing as e to the power of ln x, and I have this times ln x is equal to ln 3. So now notice how this is in the form a times e to the power of a. A in this case being ln x, so it's the form ln x times e to the power of ln x is equal to ln 3. So now if I take the W-Lambert function on both sides, I get w of ln x times e to the power of ln x is equal to ln 3, and this is just equal to a. So, and sorry, I have to take the w on both sides, so I get w of ln 3, and then now I'm left with ln of x is equal to w of ln 3. Now, I want to get rid of this ln, so I'm just going to take e to the power of both sides. E to the power of ln is, these two cancel out, so I get x is equal to e to the power of w of ln of 3. So this is my answer to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and check out other videos that are similar to these on my channel. Thank you. Alright, so in this problem, I have 1 to the power of x is equal to 2. Now to solve this, I'm going to take the natural log, or ln, on both sides. So I have ln 1 to the power of x is equal to ln 2. Now if I have something from ln a to the power of b, I can move this exponent b to the front, so I get b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln of 2. Now, if you guys already didn't know, ln of 1, this is actually equal to 0. So I have x times 0 is equal to ln 2. And x times 0 is 0, so I get 0 is equal to ln 2. And, well, ln 2 is equal to 0.693, but there is no solution because the variable x is gone. So this means that there's no real solution. However, there is still a way to find the value of x here. So, Euler's formula, this states that if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know this may seem a little confusing right now, but Just bear with me. So let's say that theta is equal to 0. Then this means that we have e times I times 0, which is simply e times I times 0, which is equal to cosine of 0 plus I times sine of 0. And cosine of 0, that's equal to 1. And sine of 0 is 0. I times 0 is 0. So I have 1 plus 0, which is equal to 1. So this is equal to 1. Now, another thing that you need to know is if theta is equal to 2k pi, which is a full-length unit circle. So in this case, I get e to the power of I times 2k pi, and this is equal to 1. So now, we know that this is equal to 1, right? And remember, our original equation was 1 to the power of x equals 2. That's what we want to solve. So what I'm going to do is I'm going to switch in 1 for e to the power of I times 2k pi. So now I get e to the power of I times 2k pi to the power of x is equal to 2. Now to solve this, I'm going to take the natural log or ln on both sides. And now I can move x to the front. So I get x times ln e to the power of I times 2k pi is equal to 2. Or sorry, ln 2. Now, this is the same thing as I times 2k pi times x times ln e. So I'm just using the ln property again. This is equal to ln of 2. And ln of e, this is equal to 1. So I'm left with I times 2k pi times x times 1, which is the same thing, is equal to ln of 2. Now to solve this, I'm going to divide both sides by I times 2k pi. So then these two cancel out, and I'm left with x is equal to ln 2 over I times 2k pi. And now I squared, remember I squared, this is equal to negative 1. So I'm going to multiply I on both sides. So I get x is equal to ln 2 times I over I squared times 2k pi. And I squared is equal to negative 1. So I get x is equal to negative ln 2 times I over 2k pi. So this is my final answer to this equation.